Good morning, good afternoon. We're just all assembling. We'll give it a couple of minutes for folks to click in. You are in the right spot for optimizing your database spend and enabling your data platform for GenAI. Also, towards the end, we'll be aligning on an offer for everyone who's attended. And so we hope that you stick around to learn about that. So with that, we're going to go ahead and kick off. And from there, I'm going to welcome Wasim from AWS and Nandan from Mactores to kick us off. So gentlemen, thank you for being with us. We look forward to diving into the presentation today. Wasim?
Sure. Thank you, Dan. So my name is Wasim Shaikh. I'm a senior partner solutions architect. My focus area is database analytics and machine learning. And I work with AWS partners and customers and help them design and modernize their data infrastructure on AWS.
Hi, this is Nandan with Mactores. I'm the principal consultant. So I head the team of engineers and consultants who work with our customers in trenches to modernize their applications, databases, and data platforms.
So let's begin today's discussion by discussing one of the most trending topic across the globe, which is generative AI. We all know generative AI has taken the world by storm, and I presume like everyone here must have at least tried their hands on or must have heard about ChatGPT. So from the ChatGPT consumer-facing application like ChatGPT, we have been able to experience how powerful the latest machine learning models have become. Generative AI, to simply put in short, is basically a type of artificial intelligence technology that can produce various type of content, including text, imagery, audio, and synthetic data. Generative AI is not magic, but I would say it is the latest evolution in a technology that has been evolving. They are powered by large language models, which are also known as foundational models. And these models are pre-trained on vast amount of data, unstructured data. What makes foundational models special is that they can perform so many more tasks because they contain such a large number of parameters that make them capable of learning complex concepts. And through their exposure to uh, internet scale data, foundation models can basically learn to apply their knowledge with a wide range of context. Right. What's more exciting about generative AI is that for customers, this generally capable models can also be customized uh, to perform domain-specific functions that are differentiating to their businesses, using only a small fraction of data and compute required to train a model from the scratch. Now, generative AI has use cases, like variety of use cases, and we see that happening across everywhere. But there are specific areas of business that are meaningfully impacted by generative AI. For example, you can use generative AI to improve customer experience through capabilities such as chatbot, virtual assistant, or intelligent contact center, which can, on the real-time basis, retrieve information from your corporate database or past interactions with the customer on a real-time basis based on the context information which the customer is providing to you. You can also boost your employees' productivity with generative AI powered conversational search, summarization, and code generation. For example, Amazon Q with Code Whisperer has been helping thousands of developers to become more productive by completing their task up to 57% faster. It can also perform vulnerability scan by identifying the use of access key and secret access key within your code, and also find dependencies or usage of open source code within your code base. You can also point it to your existing corporate repository to learn the coding standards of your organization. You can use generative AI to turbocharge production of all types of creative content from basically art, music, text, images, animation, and videos as well. Finally, you can use generative AI to improve business operations with intelligent document processing, doing some quality control and visual inspection and synthetic, and also generate synthetic data as well. Now let's see where are the industries where generative AI is transforming the business. You can apply generative AI across all the industries like engineering, marketing, customer service, finance, and sales. If I have to pick like couple of examples, let's say I pick an example from travel and hospitality. You might be familiar with Booking.com. Booking.com provides over 28 million accommodation listings and flight locations in over 54 countries. They use AWS to host over 150 petabytes of data, and they use Amazon Bedrock to deliver destination and accommodation recommendations that are tailored and relevant for the customers. Now, if I have to pick another example, let's say from the healthcare and life science industry, I would say Merck. Merck basically is a global pharmaceutical company with a over 138-year history, whose goal is to get life-saving drugs into customer hands faster and in a safe manner. They're using basically AWS services like Amazon Bedrock, Kinesis, Glue, QuickSight to solve a common problem in the pharmaceutical industry, basically the occurrence of false rejects. And they are able to deliver innovative health with the help of generative AI solutions. Now, when we talk about generative AI, um, at this stage, I would say it is safe to assume that everyone recognizes the power of generative AI. And usually, whenever you start to think about building generative AI application, it's all about building large language models, which is correct, but but that's just the tip of the iceberg, right? If you were to start to dive deeper into it, you would uncover a whole new world of things that you need to pay close attention to, which includes foundation models, which includes the contextual data that may be stored inside your corporate database. And you have to tailor the foundation models to basically access the data and provide valuable insights for the end customers or even for the business. This data has to be in the form of, this data basically is generally stored in some form of vector database. And you also have to think about the agents to automate some of this work at scale and ingestion. Now, as you understand, foundational model, the knowledge that it has, it's based on the public data. And if you were to build an application using a foundational model, it is important that you provide contextual information to the foundational model. Um, and this information can be provided using the data from your um, corporate or the data center. And when we talk about the data, right, one thing to understand is data itself has been exploding in the recent time. I mean, everything that you touch, basically, even during today, like it could be your smartphone or it could be your laptop or tab. I mean, any mechanism that you can think of is generating data in some or the other way. And we have been seeing like the cloud has changed the way how we do business, and data is hugely valuable, right? So there's no use of collecting data and not generating insight out of it. And if you have to make sure that you use data in a correct manner, you have to make sure that you build a modern data strategy. And to build a modern data strategy, what you need is a set of purpose-built databases, um, which you can leverage to migrate your data onto cloud. Now, how is it going to help, right? A modern data strategy, basically, it begins with starting the migration to the cloud and moving to an infrastructure where that can enable you to achieve the scale that you need at the right cost, while also reducing the operational burden. Because On-prem, you are responsible for not only maintaining your database, but you also have to make sure that the infrastructure is also available. And the infrastructure itself could be aging. So you have to also make sure that you upgrade your infrastructure and also upgrade your application and databases as well. So that calls for a need for a managed solution so that you can only focus on your application. Now, from our early learnings operating infrastructure at Amazon.com, we realized traditional relational databases, even though they are valuable tool, they fall short on some of the use cases where we can benefit from using other purpose-built databases, which could be, let's say, for example, you have an application which needs a key value sort of a lookup and which has requirement for millisecond latency. In that case, you can probably deploy that application on Amazon DynamoDB, which gives you millisecond latency at any scale. Now we know like 80% of the world or application still relies on relational databases. So for that reason, I'm going to restrict this discussion with specific to relational databases like Oracle or RDS PostgreSQL or Aurora PostgreSQL. And as you see, even for relational database, we have choices for you to choose commercial databases like SQL Server or Oracle or even Amazon Aurora. Now, modernization may mean different things to a different person. For example, it could be just like moving your legacy database to managed database, or it could mean altogether rewriting your application and moving your data into one of the purpose-built databases. Now, since we are talking about databases, I am happy to share that AWS has been named a leader for databases by Magic Quadrant. In Magic Quadrant by Gartner for the 9th consecutive year. Now, going back to the original topic about optimizing the Oracle deployment on AWS. So I would like to discuss the choices that you have in terms of deploying your Oracle database on AWS cloud. So you can choose to deploy your Oracle either on EC2, which is going to be self-managed by the customer, or you can choose to deploy it on RDS and RDS custom for Oracle. Now, the difference is even if you are deploying it on EC2, you still get the automation of AWS in terms of hardware. So AWS is going to be managing the hardware for you, but you will be installing and managing the database on top of it. But if you are looking for a fully managed solution, then you should consider, and I strongly recommend that you start with RDS because it gives you the most value for your money by automating some of the mundane tasks. For example, you have to make sure that the backups are done on a daily basis, and then you also have to do the health checks if you're running the same database on-prem or on EC2. With moving on to RDS custom, you no longer have to worry about those day-to-day activities and let AWS take care of it for you. Now you have options to bring your licenses on both configuration, be it RDS or on EC2. It makes sense if you're running a package application or commercial off-the-shelf application that has dependency on Oracle to run it on RDS Oracle or Amazon EC2, for example, Oracle e-business suite. But if you are running an application which does not have like a dependency on Oracle as such, but for which you need just a relational database, then you should probably look at modernizing it to a different platform to save on license cost. Now, keeping the Oracle discussion in mind, and let's say if you are just optimizing your Oracle database by moving it onto AWS or maybe Oracle on RDS, you can see your innovation velocity goes up because you are no longer owning the task of managing it, and you're just focusing on the database optimization and application optimization. And at the same time, your total cost of ownership is also going down because you don't have to spend a lot of resources managing it. Right now, as I was describing, um, you just with the adoption of Oracle RDS, you are seeing a big jump in your innovation velocity as well as a dip in your TCO. But if you have to take this even further, maybe you take a look at Amazon Aurora, uh, which is a relational database. It is built with the capability or compatibility with MySQL and PostgreSQL, and it comes at 1/10 of a cost of a commercial database, and it provides almost all of the features that you can get in commercial databases like Oracle or SQL Server. Now, it can give you 5 times of throughput of communities MySQL and 3 times of throughput of PostgreSQL. It is highly available and scalable, and it does have an option of creating global database that can give you a DR configuration to start with. So, I mean, to learn more about it, please feel free to ask some questions, and we are happy to do a separate session just focus on Amazon Aurora. For now, let's move on, and we go back to our topic of how do you manage data and generative AI together. Now, as I mentioned in the past, generative AI, the knowledge that it has is limited and it is trained on publicly available data. Now, if you are building an application, you have to make sure that you provide your corporate or like internal data that you store about the customer inside your database to the generative AI models. Now, how you can do that? So the first approach that you may take is like you train these models with the data that you have. So you use these foundational models, and then you provide the domain relevant data to train this model as input, and the more likely it is to output based on the domain space. Now, the second approach, instead of training, is like what you can do is like maybe fine tune the model. When what do I mean by fine tuning is basically you provide it like more generalized set of data with some labels based on your domain, and it can train on that data. The third and the most commonly used model is like context engineering using RAG, and we'll see what that is. But what it means is like you're neither training or neither fine tuning, but your data is still inside your database, and you integrate it with your foundational model such that it can read the data and provide the insights or the information to the generative AI application. Now, if I have to look at it, all these three approaches together in terms of simplicity as well as uh, cost efficiency. If you look at this pyramid, you see training this model with the data is going to be a very complex procedure for you, and it needs like specialized skills as well. If you compare that with fine tuning, which is still a little easier thing to do, but you still need to spend a lot of resources to make sure that you do it right. For most customers, we expect at least for 80% of them to be using context engineering using RAG models. And what exactly that means is like, as I described, you will have your data stored in some form of vector database, and the generative AI application can retrieve the information from the vector database. Right now, how does this work? I mean, since we have been talking about context engineering using RAG, let's see how it's going to come into play. So you will have an application or a request coming from the end user asking about a specific information. For example, you see, I have a question here which says like, how much does a blue elephant vase cost? Now, this information might not be available to the foundation model because foundational model is trained on a public data, and this information could be internal to your database. So what you need to do is, if you do not provide any additional context information, most likely the response the foundational model is going to give is like, sorry, I don't know, or I don't have this information. Now, rather what you can do is like you can augment this data to your foundational model in the form of RAG, and you can basically have some knowledge base where you are storing this information. That knowledge base could be a database storing your product catalog and pricing for each product. The foundation model can then go and read that information from that knowledge base and provide the right answer to the customer or the application. So now, with the help of knowledge base and RAG, the foundation model was able to answer that the blue elephant vase would typically cost around like $99.99. Now, one thing to understand that the information or data that the foundational model works on is basically stored in the form of embeddings, or I would rather say vector embeddings. This vector embedding basically refers to the process of transforming objects such as text, images, video, audio into numerical representation that reside in a high dimensional vector space. This technique is achieved through the use of machine learning algorithms that enable basically the understanding and the meaning of the contextual data, a semantic relationship, I would say, and learning of complex relationships and patterns with the data syntactical relationships. Now, you can use this resulting vector representation for a wide range of application, such as information retrieval, image classification, natural language processing, and many others. Uh, when you think of vector, think of it as an array that represents a sequence of bytes or text. Foundational model converts all input data to vectors. So this is the example of a three-dimensional vector space with training data. You will observe that the terms are organized in groups, and these groups are referred to as clusters. Uh, Vectors within the group have a close semantic relationship with vectors within the same cluster. Now, as you see, there are three groups here: furniture, financial terms, and books, and they share common characteristics with each other, right? Now, how vector embeddings are used, right? When it comes to RAG, how are they used? Let's see. So you have your data probably stored inside a PDF document. Then what you need, basically what foundation model will do is like it will break this document into chunks, or you can break this document into chunks, and then pass it through a foundation model. For example, what I have here is a Amazon Titan embedding model, which will convert it into vector and store it into one of the vector compatible database. For example, I have here Amazon Aurora, but not necessarily that is the only database available. You can choose to use OpenSearch as well, which is also one of the commonly used vector databases among the customers. Now, we have stored the data or the PDF document inside the vector compatible Aurora PostgreSQL. And when a user ask a question to the generative AI application, what will happen is like the model will embed that question or the contextual request into the embedding and try to retrieve that information from the PostgreSQL. And once it is able to locate that vector, it will then combine the question with the contextual data and return the response back using one of the language model. So for example, I have here Cloud V2. Now there's a Cloud V3 version as well. And it will share the response back to the customer. Now, I'm happy to share that we have extended the vector capability to almost most of our database services, which includes OpenSearch, Aurora PostgreSQL, RDS PostgreSQL, and we are continuing to add vector support across our other purpose-built databases as well, including MemoryDB, Napkin Analytics, DocumentDB, DynamoDB as well. Of course, not directly on DynamoDB, but you can have a zero ATL integration with OpenSearch, and OpenSearch itself supports vector database. Now, I understand migration can be complicated and it can be tricky, and there is a risk associated with migration. Keeping that in mind, we do have resources for you to assist with your migration journey. One such example that I can talk about is database optimization and license assessment program. Now, what it does or how it can help you is basically we have created a program wherein which can help you as a customer understand the licensing that you own and how you can optimize it when you decide to migrate your databases to AWS. Now, this is an example of a Microsoft SQL Server license assessment, but similarly, you can use it for your Oracle licenses as well. So if you're already running Oracle databases on-prem, you may have a bunch of licenses and you would want to make sure that if those licenses can be imported onto AWS. So what we have is a set of specialized AWS partners, like one of them being Mactores, who have capability in analyzing the licenses and providing recommendation when it comes to migration. And this assessment is basically free of cost to the customer, and it's been funded by AWS, so customer basically does not pay anything, and they would get recommendations based on the assessment output. Now, the advantage is it will help you assess and optimize your current on-premise environment when moving on to cloud. Now, what typically happens is when you have a database running on cloud, you typically over provision the resources because there's not a lot of scalability when the database itself is running on prem. But when you're on cloud is built for the scale, right? So you don't have to over provision. So it makes sense to optimize your footprint based on the usage and come up with the right recommendation. So that you can get from the database OLA program. And of course, it will have indirect impact on your cost savings because now you're no longer provisioning more resources than required. Um, you will also get expert license advice to validate if your licenses are capable to be moved to the cloud or if there are certain blockers that may prevent you from doing so. Um, and as you understand, it is also going to optimize your capacity requirements as well. Now, what are the other benefits when it comes to OLA program? It can also help you build a business case based on your current utilization, your licenses, and their validity. And it can also identify the workload that can move to a managed database. It could be commercial database, or there is an opportunity to modernize it to open source and reduce the licensing cost. Now, to continue this discussion further, let me call upon Nandan Umarji, who is basically a principal consultant from Mactores. And Mactores is basically one of our AWS partner with deep expertise in data migration and modernization. Nandan will demonstrate how you can de-risk the migration and efficiently handle various stages of migration for assessment, um, uh, which includes schema and data migration using GenAI-based tools with the help of a demo and discuss some customer success stories as well.
Let's talk about risks within the migration process. Like about over 60% of database migration projects fail. A lot of them, they fail due to like application and databases being currently updated during the migration process. Many applications have and databases have complex integrations and different application dependencies. And about 57% of databases lack comprehensive documents. One of the other scenario is that we try to approach this problem with expensive consultants or with full-time employees. It involves a lot of human hours, and therefore it is prone to errors. In realistic scenario, about 70% of companies have situations wherein one application is connected to multiple databases or multiple apps are connected to single databases, out of which about only 24% have appropriate version control documents for application and database version, which means what's running in production may be different than what's running in dev, what's running in QA, and what's running in all other environments, which just make it more complicated and kind of there are other bigger impediments that are hurdles to all of these migration situations. Many companies have apps with 15% years of legacy, which also includes things like outdated technology stack. Like there are many companies still using JSP, or many companies using the monolith web application. The challenge with these monolith applications is that they don't scale. And in order for them to scale, you have to always scale up your application and your database server. You have to always vertically scale as opposed to evaluating options of scaling those applications horizontally. These things at times lead to a lot of downtime, and they need more operational support, and it incurs 40% of more technical debt. In those historic times, most databases were built as relational databases, irrespective of the use cases, because that was the only type of database which was available. And they have challenges in terms of schema rigidity, scalability issues, and lack of flexibility for no SQL use cases. And companies carry these legacy databases over the period of time. A lot of databases and applications are like undocumented. So essentially, we do not know which part of the application connects to what type in database. Does it connect to one schema, multiple schema, and so on and so forth. Issues related to application code compatibility. Let's say, for example, if any company decides to migrate database engine from one database to the other, there is always a change in terms of SQL syntax. Different databases, like stored procedures, might be different in Oracle versus stored functions within Postgres, and so on. Multiple databases have different data types. They have different ways in which they manage constraints and keys. And then there are always challenges with object mapping, and if there are any ORM type of situations. So all of these scenarios, including the downstream data pipeline compatibility, including different ETL applications, including different data pipelines, also create significant problems in the migration process if they are not discovered earlier. With Mactores process, what we try to do is we try to de-risk all of this process, right from the assessment, design, build, application code, database, integration code conversion, data one-time snapshot, and change data capture, along with testing all of these scenarios in an automated way for schema, for data accuracy, for code, for application integration, load, security, and having a proper cutover plan with the rollback. With this process, we try to de-risk the entire phases of migration. Each of these phases are extremely important. Like the first, it starts at licensing assessment. So what happens in licensing assessment? I'll just quickly bring up the different part of my screen and start sharing the challenges related to license assessment and how do we try to address them. I hope you can see a screen which has a QuickSight dashboard. So typically during the assessment process, we deploy our tools within your Oracle environment, and then we find all of these details, like which of the Oracle versions is included with like what operating system, what is the licensing cost. Then there is infra server summary, on-premises infra summary, what type of instances do you have for what CPU model, what's the infrastructure cost, storage cost, what is the cost distribution. It includes analysis on what does CPU utilization look like, what does memory utilization look like, what is the licenses utilization, purchase versus licenses. We also discuss about how many instances, how many of them are database instances, how many licenses, what is the number of CPU cores, etc. So it can be very clearly established in terms of what's been purchased versus what's been consumed and what is really required. Now, at the end of this, like there is another outcome of this exercise is that we try to calculate cost of all of these scenarios annually, when like in comparison with what's the present situation from an application perspective in terms of what's the infrastructure cost, what's the infrastructure and license cost, and what's the infra license and administration cost. And then we present multiple options, like what does it cost, like from Oracle on EC2, if somebody decides to go from Oracle on RDS in a BYOL scenario, what will be the total cost of ownership will look like from an infrastructure perspective, from an infrastructure plus license perspective and for infra license and administration perspective. And you look at, and if you look at the situation, like if somebody decides to move to, let's say, Postgres or MySQL on RDS Aurora, which is like the purpose-built databases on Amazon, the licenses cost actually goes to zero. Infrastructure cost gets optimized. In a lot of places, administration cost reduces because you simply do not need way too many people to run your 24/7 database operations. And a customer can actually save close to 82% of their, like, the cost of running application and databases in comparison with on-premises with Oracle. And obviously, all of this migration comes with a lot of risk, and there is an approach to de-risk that migration. And we'll talk about that in just a little bit. But in short, like, there are different approaches to this migration. Oracle on EC2 BYOL gives you infra saving up to 43%. Oracle on RDS gives you infrastructure saving up to 22.83%. But the highest is if somebody decides to move to Postgres on RDS Aurora. Next, we are going to cover like a demo scenario in which we spoke about a business case that included 176 servers. We established that if somebody decides to move these applications and databases to Oracle, from Oracle onto Postgres on Aurora, they can potentially save 80% of their cost while doing the migration, which essentially means that the entire migration effort is paid for itself by the savings that is achieved within the licenses in about few months' time. Now, when it comes to technical portion of the of this migration, we will take a look at an e-commerce application which is based on .NET and Oracle. And we will try to look at what are the different situations which are involved in this migration and how do we actually cross that one step at a time. At an outset, we really don't know which applications are connected to what databases. So we deploy services in your infrastructure, which will actually tell us about what is the application infrastructure and which application infrastructure connects to what type of database. And with this trace, we try to establish what type of APIs exist within the application and how much they are loaded, resulting into what type of CPU consumption, memory consumption, and storage consumption, which helps us establish from the data, like when we do the migration, what type of approach we need to take. Is it going to be like, do we require a polyglot approach? Do we require an approach which will mean that we are migrating certain portions of Oracle to Postgres and DynamoDB? Are there any time stream DB use cases? We do data-driven assessment to figure that out and help customers understand how to go about each of these processes. So once that is done, one of the bigger challenges in this entire process is about how do I convert schema and how do I convert these 200, 400 stored procedures. Like, we have generative AI tools to address that problem. So in all of these database objects, like obviously, let's try to take few examples of the database objects. Let's say that in our Bob bookstore, the sold as in the book application, we want to retrieve top 5. We have a query that will retrieve top 5 best-selling authors, best-selling books along with their authors. So like this is what the Oracle query looks like. And as I hit convert, this query now will be automatically converted to something which is Postgres compliant. And then, so the scenario is that this generative AI-based tool has capability to convert many complex queries. I'm showing this to you in the form of UI, but in an actual project implementation, this all becomes an automated process wherein all these queries, which are all these 200, 500 queries which are in Oracle, they get converted into Postgres. In a fraction of time, the entire database queries get converted. And then with the automation test mechanism, we can actually unit test if those queries are converted successfully. In our past few database migration experiences, we have realized that this tool can convert up to close to 95% accuracy. This tool can convert 95% of objects quite successfully. Moving on to the next portions of the migration. Now, let's say that everything is migrated into Postgres. Now, there is there is always a situation, and there is always a situation wherein you have to migrate data. And when the data migration happens, it can be of two types: one-time migration and ongoing changes. And show you what does that validation look like. So this validation is automated, and when the data migration is complete, this produces a report like this. This produces the report on each table: how many rows were there in the table, how many rows matched, how many rows are different, and it actually classifies things as different. What are the different rows? What are the missing rows and what are the extra rows? Now, different rows can happen because of the data type mismatch, and maybe half of the data in certain columns is migrated. At times, certain rows are missed. At times, certain rows are added extra. So this tool gives us very clear understanding and very clear confidence that all of our records are successfully migrated from the older database to the newer database. And this confidence is extremely important before we start our testing cycle and before we plan for any type of cutover strategy. So we use our custom tools to make sure that we bring confidence into this database model, this database migration or data migration scenarios, in addition to what's possible with AWS DMS. So now imagine that all of this data migration is done, application is in production, and like there are always generative AI use cases with every application. And this application is no different to that. So again, this is a used bookstore application. And then we may have a lot of questions for this bookstore based on its data, based on the content on the book. Now, let's just say that we want to generate a book description for the marketing purpose, for marketing these books better. So I again go back to the generative AI tool, which actually connects to this database and has access to this database. So let me try to put a prompt wherein I'm trying to ask a question like, generate a book description on one of the book for Gen Z book readers, which means I'm trying to target specific generations of readers so that they are enticed to a story. Now, because of being able to migrate to Postgres on Aurora with the vector DB integration, all this data which is present in the Postgres, the generative AI model, which is hosted out of Bedrock, is able to read the data from those books and is able to construct useful content which can be useful for this business to promote their book offerings. It can also write like promotion emails if we target the specific age group. So like, for example, I'll write another prompt which says, write a promotional email to age group between 15 to 25, pitching top 5 similar books to one of the book. And then it will do that. Company can use it to promote their books to their set of readers and so on. And obviously, they get to moderate what goes on in actual emails, but this serves as a handy tool for customers, which uses their own data, their own model to get the outcome which can be unique to their businesses. Now, at the end of the day, whilst all of this is fantastic, the most important part is how do we manage cutover and what are the possible challenges that one can face during cutover exercise, and what are the options to kind of roll back if that becomes necessary. So let's review through the cutover strategy. Like during cutover process, we typically create one more parallel infrastructure, which has the application, which has the new version of application with the Postgres database. So there is like application red, which has like, which is the original application, which connects to Oracle. And then there is new application yellow, which connects the new application into Postgres. And the ongoing changes, like once the data is full loaded and validation is in progress, the ongoing changes are actually the ongoing changes continue to happen from Oracle to Postgres consistently. At that point in time, users can actually test the test users can actually test the Postgres application in a read-only mode because the data is still being ingested into the Oracle application, which is the red application. Now, at an appropriate time, we decide to stop that change data capture process and move traffic from the red application to yellow application. So, which means that users are now which means the yellow application is now live, and users are actually ingesting data into the yellow application, and the red application is in the stop mode, which means nobody is using that. And obviously, when we make sure that all these yellow application is successful, then the current application, which is the red application, which can be stopped and eventually be decommissioned. So this process ensures customers to have very near zero downtime based cutover exercise while ensuring minimum impact to its users. And in case of rollback situation, the yellow application can be taken down and the traffic can be sent to the red application. And the change data capture, the CDC, the reverse CDC can happen from Postgres to Oracle. If for any of the scenario you need to do that, there is always a chance to do that. So this is how in each of the processes, including starting from your licensing assessment to the load analysis, to the object conversion, to data migration, to data validation, to automated object conversions, also to integration with the modern day GenAI tools, this process is designed to de-risk migration and help customer achieve the desired goal of about 80% cost savings in migrating those databases from one platform to the other. Now, it's not just the talk. We have proof points to this. Like one of the branded payments leader, they retired their technical debt from like kind of migrating their marketplace application, which contained like Java, Hibernate, and Oracle. And we migrated that successfully to Postgres, which resulted into like 4x performance and about 70% of efforts in operational cost. They saved close to $3 million in licensing and enterprise supporting cost over the period of time. And from the perspective of sheer managing resources, managing like Oracle admins, DevOps engineers, they saved close to $2.5 million in resource and efforts. We have many other customer successes in the form of Seagate, EMD, HP. Should you have any questions about any of the case studies, we are happy to answer them on this conversation or during one-on-one conversation with any of you. Now, as Wasim mentioned in his talk, that people who attend this webinar, they have there's a webinar offer for them in about $20,000 in value, wherein you get free migration assessment and report, different architecture options, optimized license analysis and insights, the strategy, migration efforts, and TCO report, risk and mitigation strategies, and then report document and executive presentation of the entire assessment, which can be asset to the business should you want to embark this journey of migration in the near or distant future. Thank you.